Welcome to a new series of receiving. In this series, we're gonna provide you techniques and various of basic electrical engineering. For this video, we're going to use mesh analysis in order to identify the current flowing through each meshes and then output power across all the EMFs given in the network. We are going to use mesh analysis for this particular questions. And if you have noticed this one, we are writing type 1. The reason of writing type 1 for this question is for the questions where for the circuit in which resistor and EMFs are only present, we are considering these circuits as type 1 circuit. Particular circuit, we are already provided the total number of meshes. So you can notice, as you all know, the closed loop or the closed circuit or closed path where the current flow, we called it as a mesh. We are having total 3 meshes in the given circuit. This one is mesh 1, mesh 2, mesh 3. And along with the name of mesh, the direction is also assumed. We are assuming all the currents are flowing in a clockwise direction, and current flowing through mesh 1 is I1, current flowing through mesh 2 is assumed as I2, and current flowing through mesh 3 is I3. So all of these are provided in questions, but question may not always have all of these information. So if these informations are not given, students have to assume it by themselves. So get clear to it, and once it is done, now let's initiate to provide or to assign sign to each circuit elements. As the current, since this current is assumed in this direction, so we gonna provide the sign to each circuit element. But one is for voltage source, this source, the sign is already given. So the sign of voltage source or the polarities of voltage source remain constant. They are independent of direction of current flow. What I mean is, the positive sign of voltage source will always remain positive, and negative sign of the voltage source will always remain negative, no matter whether you assume the direction in clockwise direction or you assume the current in counterclockwise direction. Once that is clear, you have to initiate to provide the sign. After this, we have to go through clockwise direction because the direction assumed in this mesh is clockwise. So after this, you can't return back, you have to go forward only. So as the current is in this direction, if the current was in opposite, we would have gone this way. Okay, I hope it is clear to you. Now let's initiate. As we all know that the current flows from higher potential to lower potential, so for that case, current will move from this. So we are going to write this as a higher potential and this one as a lower potential. Similarly, current will flow this way, so this will be positive, this will be negative, this will be plus, this will be minus, plus, minus, plus, minus. That your concept get clear. Once you get clear, the chances of getting mistakes or getting confused will reduce, so you can watch this again to be clear. Let me erase all of this. This is done. Now you have to assign all of the sign that before applying or before implementing Kirchhoff's voltage law. So now let's move to mesh 2. For the mesh 2, look, the direction is again in clockwise direction. Okay, so we'll move from this. Current will obviously enter from this point, so we are writing plus, and current will exit from this point, we are writing minus. Current will come to this position and will enter from here, exit from here, enter from here, exit from here. And again for the voltage polarity, it doesn't matter from where current enter or current exit, it is independent of direction of current flow. So this one, the longer will be terminal will be positive always, and this shorter one will be negative, so plus to minus. Similarly here will be plus minus. Once this is done, let's move to mesh third mesh. Over here the current is entering from this, exiting from this, entering from this, so we'll write plus sign, minus sign, plus sign, minus sign, plus sign, and minus sign. Again, for voltage source you are not going to notice the direction of current flow, you are just have to notice the positive term polarity and negative polarity of your voltage source. That's all. Once all of them are done, we have to apply Kirchhoff's voltage law in each meshes. And before applying Kirchhoff's voltage law, first thing you have to remember is, if your flow of sign is from positive to negative, you will be write what sign, or if sign is plus to minus, minus to plus, the sign will be, you can remember this, higher potential to lower potential, or from positive to negative means always negative, that's why write negative sign. If something is was negative in past but is positive in present, means it's a positive scenario, so we will write positive sign to it. After remembering these things, can apply Kirchhoff's voltage law. Now let's apply Kirchhoff's voltage law for mesh 1. On applying Kirchhoff's voltage law on mesh 1, we get what we get. Now we are writing, we all know that Kirchhoff's voltage law states that the sum of EMFs and voltage drop across each resistor in a given closed circuit is equals to 0. So we are going to use this Kirchhoff's voltage law on each meshes. First let's initiate from mesh 1. In mesh 1 we are going to follow the same path which was assumed previously, so you can initiate from this point, this point, this point, as per your wish. Let's initiate from this point. Now while initiating you have to remember these points. Look, while current move from clockwise direction in 5 ohm, what we find that the sign is going plus to minus. Plus to minus means minus, so we will write minus 5. But writing 5 won't be sufficient, because sum of EMFs and voltage drop and resistor, it's a 5 is resistor, so voltage drop across 5 ohm is 5 into I, and since I1 is flowing through this mesh, so we will write 5I1. Okay, once this is done, you go to this 10 volt, so that if you will follow a pattern, the chances of getting mistakes will reduce. That's why next one is 10 volt. Now notice the polarity or sign, it's minus to plus, so we'll write plus 10 volt. Okay, and then go to 2 ohm resistor, it's again plus to minus, so we'll write plus to minus is a positive to negative. Obviously positive to negative is negative, minus 2I1. After that 3. Okay, for 3 also minus 3I1. Okay, then for 5 also minus 5I1. Now you have to be more careful at this point. Once you get the idea what to do in such case, get problem further also. So let me explain it again. Since 5 ohm lies between the mesh 1 and mesh 2, so in 5.1 you will notice that I1 is also flowing in 5.1 and I2 5 ohm, and I2 is also flowing in 5 ohm. So for this case, all you have to do, you are now dealing with mesh 1. That's why you can't change the direction, so you have to go in a clockwise direction. For that case we are going for a clockwise direction, and we find that current I1 goes from plus to minus, that's why we write minus. But from going to upward to downward, we find that I2 flows minus to plus, so we'll write plus 5I2. Okay, Then for next one, this 5 1 will again see this position, which is plus 2 minus, so we'll write minus 5 I1. Again there is a I3, which is minus to plus, while noticing from upper side to lower side. So don't get confused, you have to see the direction of the mesh in which you applying Kirchhoff's voltage law and the sign of opposite mesh. So while noticing that, we find that plus 5 I3, okay, is equals to 0. So this is the Kirchhoff's voltage law. Now add the like terms, 5 5 5 5, which shows that we are having 20 I1, okay, 5 5 5 5, and then I2. When it comes to I2, there is a minus 5 I2 and then minus 5 I3 is equals to 10. I have written this in a simpler form. You can easily understand this one. And now once it's done, let's initiate to apply Kirchhoff's voltage, because there are 3 unknown variables, I1, I2 and I3, and in order to identify 3 unknown variables you will require 3 equations. So again applying, what will you get? Now for the second mesh, this one is making, you can start from anywhere. I'm starting from 7 ohm, okay. This is 7, sign plus or minus? Minus, obviously, because plus to minus, okay. So minus I2, then 3, plus to minus, it's minus 3 I2, after 3 it's 5, which is plus to minus, so minus only because it's a voltage source. After that, after 5 it's 5, again the same case come. For the current I2 flows from plus to minus, okay, so we'll write minus 5 I2, but if you will notice I3, it's going minus to plus, so plus 5 I3. Similarly, once this is done, we'll write for next 5 ohm, which is minus 5 I and then plus 5 I1 is equals to 0, okay. Now once it's done, we'll again initiate to write, which will be equals to 5 I1 then minus 20 I2 minus 5 I3 is equals to minus 5, okay. This one will be equation B. Once equation 1, equation B are done, then let's apply KVL. Again applying KVL in mesh 3. While applying KVL in mesh 3, you have to notice the meshes. Let's start from this point, this 5 ohm. It's minus plus to minus, minus 5 I3, then minus 5, then minus 5 I3, then plus 5 I1, then minus 5 I3 plus 5 I2. Hope you are relating it well. Why minus? Plus 2 minus, that's why minus, then plus 2 minus, that's why minus, then plus 2 minus, that's why minus, then for same direction minus to plus, which one is I1, that's why, then plus 2 minus, minus, then minus to plus, that's why plus. After weighing this, now add all the like terms, or it's minus 5 I1 minus 5 I2 plus 15 I3 is equals to minus 5. It's equation third. Now easily solving equation A, B and C. After solving equation A, B, C through calculator, you can easily identify the value of I1, I2 and I3. The value of I1 will be 0.37 ampere. The value of I2 will be minus 0.23 ampere, and the value of I3 will be minus 0.29 ampere. The some negative sign indicates that the assumed direction was reverse, or in other way, you assume the direction of I2 and I3 in clockwise direction, but in actual case the current was flowing from counterclockwise direction. That's why the negative sign came over here. So you need not get to worry about the negative sign. It can be positive, it can be negative. Your assumed direction might be in the same direction or can be in a opposite direction. Now once the currents are identified, it's very easy to find the voltage drop. If somebody asks you to identify the voltage across this 5 ohm or voltage drop across HG, all you have to do is the resistor R, which is 5, into current flowing through it, which one is I1. So into I1 you can easily identify the voltage drop across it. And if you are asked to identify the output power, then what will you do? To identify the output power, all you need through each source, let me identify the value of all the currents. If you identify the power output from the source, then you get the source from, we know that source of 10 volt is equals to output power from 10 volt is equals to 10 into I1. How much I1 you are identifying. Similarly, for if you are asked to acquire the output power from 5 volt, all you will do is source of 5 volt is equals to 5 into, in which is 5 1 is okay, let's consider for I2, so it will be I2. That's how you will identify power. And if you are asked to identify the voltage drop across 3 ohm, then you will do voltage drop across 3 ohm is equals to B. We all know that B is equals to I into R, and R is already, and this case since I1 current is flowing through 3, that's why we'll write I1 value and resistor into 3 into I1. If you are asked to identify the voltage drop across this, you will write 5 into current flowing in between this resultant of this current. If this coming in clockwise, it's in counterclockwise, you can write this minus this. So that's how we can solve the problem of mesh analysis where resistor and EMFs are only existed. Hope this video is gonna help you. Thank you.